1 gallon per minute of H2O is eliminated from 20,000 CFM of moist air during a dehumidification process. The air enters a cooling coil at 98 degrees Fahrenheit dry bulb, 81.3 degrees Fahrenheit wet bulb for this process, and exits at a saturated temperature of most nearly what? Initial critical thought solution elements. 1. What are you solving for? The saturation temperature of moist air exiting a cooling coil. 2. What is the fundamental process? Dehumidification of moist air. This is an air conditioning process which indicates a psychrometric analysis. Conditioning air's temperature, humidity, or enthalpy strongly indicates psychrometrics. If this is unclear to you, then you don't understand psychrometric charts. There are many resources explaining these charts in depth, from ASHRAE Fundamentals Chapter 1 to YouTube videos. 3. What are the first considerations to find the solution in connection to the fundamental process? The dehumidification process removes mass of H2O, so you should initially look for mass flow indicators. None are given in the problem, but there are volumetric flow values. An extremely common process for PE problems is converting between mass flow, which is pounds mass per time value like minutes or hours, and volumetric flow, which is cubic feet per time value like minutes or hours. This is done using density, which has the unit pounds over cubic feet, or its reciprocal, volume, with units of cubic feet over pounds. 4. Are there key assumptions? Yes. First, assume sea level conditions for psychrometric analysis, as no other altitude is given. You must always identify altitude when considering air conditioning processes. Second, assume steady flow conditions for energy transfer. This assumption is nearly universal for PE problems. Third, you must assume that the water being removed is standard in its density, specific weight, etc. You are given inlet conditions of volumetric airflow and temperature. You are told that a certain amount of H2O is removed during a process, and you are asked for exiting conditions. This is a cooling process, and it's clear that the air temperature has changed, which indicates energy transfer in a steady flow process. The problem also indicates that the exit condition of the air is saturated. Determine the mass flow rate at the inlet. From Psychrometric Chart 1, look up volume, that is, cubic feet per pound, of air at 98 degrees Fahrenheit dry bulb, 81.3 degrees Fahrenheit wet bulb. This is 14.5 cubic feet per pound. The density reciprocal is approximately 0.069 pounds per cubic foot. Multiply this by the volumetric airflow at the inlet. 0.069 pounds per cubic foot times 20,000 cubic feet per minute equals 1,379.3 pounds per minute. Notice that the psychrometric chart says that the volume is cubic feet per pound of dry air. You need to connect this with data indicating what amounts of water are in the air. Most specifically, what mass of water is in the air. Focus on how you would find a unit-based conversion from the mass of dry air to the mass of water in it. Humidification and dehumidification are processes that fundamentally represent change in the humidity ratio of the air. That is, a change in the y-axis of the psychrometric chart. Here is the unit conversion you need. Pounds of moisture, that is, mass of water, to pounds of dry air. The humidity ratio of air at 98 degrees Fahrenheit dry bulb, 81.3 degrees Fahrenheit wet bulb, is 0.0196 pounds mass per pounds dry air. From here, it will go down by some amount. It will have a smaller humidity ratio because of dehumidification. That's what needs to be found next. The problem says that 1 gallon per minute is eliminated. There is a conversion from the volume of water in gallons to the mass of water in pounds. Find this in the NCEES Mechanical Reference Handbook, Section 1.1, Conversion Table. 1 gallon of water equals 8.34 pounds of water. There are two ways to bring all this data together. You could either look up the appropriate equation in the NCEES Mechanical Reference Handbook, which is found in Section 9.2.2, Moist Air Cooling and Dehumidification. Or you could use critical thought. Here's the critical thought option. Remember, the mass flow is dry air. Dehumidification won't change dry air. What is changing is the humidity ratio, and everything must balance. Nothing in the process simply disappears. Dry air with a particular humidity ratio enters the coil at a flow rate. Water is extracted by the cooling process at a flow rate. And dry air with a lower humidity ratio exits the coil at a flow rate. The extracted water flow rate must equal the differences between the inlet and outlet flow rates. The inlet flow rate of 1,379.3 pounds of dry air per minute times 0.0196 pounds of water to pounds of dry air minus the water extraction rate of 8.34 pounds of water per minute equals the outlet flow rate of 1,379.3 pounds of dry air per minute times the unknown humidity ratio. Confirm unit cancellations and do the simple algebra, and the solution is 0.0136 pounds water per pounds dry air. On the psychrometric chart, connect the humidity ratio of 0.0136 to the saturation line to find an approximate saturation temperature of 65.06 degrees Fahrenheit. To get good at questions like these, you should study ASHRAE Fundamentals Chapter 1, especially Section 10, with examples 2 and 3 using equations 41, 42, and 43. Do ExOverZero drillbook practices to familiarize yourself with the NCEES Mechanical Reference Handbook, which needs to be referenced at least 2 times for just this one problem. Remember, the average PE question should only take you 6 minutes.